Hello, everybody. Welcome back. In this module, we're going to start in risk management theory. So this is going to be something probably completely foreign to most of you. So I would think you'd want to pay attention. And of course, there will be questions about this. Well, let's get into it. All right. The information we're talking about here is based on these things. ISO, which is International Organization of Standardization. I know it doesn't fit ISO, but that's what it's called. 31,000, excuse me. And it has the ANSI number too. And that's mostly for enterprise risk management. In other words, for the whole company. ISO guide is vocabulary for risk management. And these are ISO 31010 is risk management techniques, and ANSI is prevention through design, or PTD, which is more closely aligned with the rules of EHS manager, or environmental health and safety managers. So this is where this information is kind of coming from. If you search YouTube or Google risk management, you're going to get a lot of results, but many, if not most of them, will yield something that pretty much follows the steps that we're going to go over here. This is a definition that happens a lot. There's a lot of definitions, but this is the one that comes up a lot. So I'm going to talk about here. Stakeholder is a person or organization that can be affected by, or perceive themselves to be affected by a decision or activity. So throughout this, if they say you have to communicate with the stakeholders, that's basically anybody that's pretty much that's involved in it or can be involved in it. So the risk management process generally covers these steps. Establish the context, and we'll talk about each one of these individually. Risk assessment, which includes risk identification, risk analysis, risk evaluation, and risk treatment. And then monitoring and reporting. Did the risks work? Did risk treatments work, excuse me. If not, make necessary adjustments, maybe even start over. Report results as necessary, maintain awareness of any possible changes, and continue monitoring and adjust and repeat as needed. During this entire process, of course, the entire team should be communicating and consulting with one another. Again, we're going to look at each one of these steps in much more detail. The first thing you want to do is establish the context. In other words, set the purposes and scope of the risk management process and define the criteria against which risk will be assessed, such as the goal of the process. Right? What are you trying to accomplish here? We're going to get together and we're going to do something, but what do we want to accomplish? What specific jobs, task area are covered? All right, you need to do one department, the whole plant, just whatever. Just define it what it is so you know what you're going to be doing here. Which risk matrix will be used? Again, if you Google risk matrix, you're going to find probably 1,000 different risk matrices out there. And which one are you going to use? We're probably going to use the 5x5 one that you've introduced to. There are all kinds out there, and we'll cover some of them later on. But so you have to decide, well, which one are you going to use? Will a prevention effectiveness factor be included? We'll touch on that a little later. But a prevention effectiveness factor is usually associated with the controls you put in. In other words, your engineering control, that's probably a pretty high risk effectiveness factor. They're pretty effective. So if you do that, you can take that risk before you put controls, divide that by the effectiveness factor to get a revised risk factor. A detection of failure factor be included. In some cases, they include this because detection of failure can be a factor in the risk. In other words, if something is easily detected, it's probably going to be less of a risk because you can catch it quicker. If it's hard to detect, it could go on for a while and be quite a greater risk before you detect it. So these are some things you have to establish in the context. All right, who is going to participate in this process? Of course, your safety professionals are going to do it. Machine operators, probably supervisors, probably, maybe some outside consultants. But again, it depends on the complexity of the process and a lot of other factors, who has knowledge, experience, whatever. But you have to determine that up front, who's going to participate in this process. Now, you can always add people later on, of course, but that's a good idea to do this when you establish the context so people are in on the ground floor, so to speak. And this is to formalize this, to make this a formal thing, would probably take place formally in a large company or a very involved process. In a medium-sized or smaller organization, going to probably most likely done by the safety department, who should get input from as many additional personnel as needed. So this can be as formal as it needs to be, but informal in a lot of cases too, establishing the context part of it. Risk assessment Again, risk identification, finding, recognizing, and recording hazards, risk analysis, understanding the consequences, probabilities, and existing controls, and risk evaluation, comparing levels of risk and considering additional controls. We can talk about all these later too. Risk or hazard identification. A hazard is basically the potential for harm. Hazard analysis is a process that commences with the identification of a hazard. Got to identify it first, you know what you're dealing with, or hazards, and proceeds into an estimate of the severity of harm or damage that could result if an incident or exposure occurs. You know, so they say estimate, because you can't be 100% sure what's going to happen. The risk is an estimate, again, an estimate of the probability of a hazard-related incident or exposure occurring and the severity of harm or damage that could result. So identification of hazards is the most important step in risk assessment. Hazard identification includes existing and potential hazards, potential exposure to hazards, possible failure modes. We're going to talk about those later, failure modes, events or circumstances that can cause or trigger a failure mode or present an exposure, existing controls, potential consequences. And again, to repeat, identification of hazards is the most important step in risk assessment. Makes a little bit of sense, doesn't it? If you don't know it's a hazard, you can't really do anything about it. The existence of a hazard alone does not necessarily translate to a risk, which is exposure to a hazard. Exposure can occur in various ways, including direct contact with a hazard, indirect contact with a hazard, proximity to a hazard, duration of exposure could be a factor, magnitude of exposure, how big the exposure is, or how much chemicals or how temperature or whatever, but the magnitude of it, concentration or dose of exposure, these could all be factors. For example, an ungraded chain and sprocket that's 20 feet above the floor working surface is a hazard, but since it's out of reach of everybody, there's very little risk. But if it was 3 feet from the floor, it would be a risk to all who would be near it. So to analyze, evaluate, and control the risk, it is necessary to identify the exposure routes or pathways for identified hazards. Failure modes are functions that do not perform within a defined parameter, perform inadequately or intermittently, and do not perform as intended. A simple what-if approach can be used to help identify potential failures in a system. Examples of failure modes: premature operation, in other words, unexpected startup or release of energy. Failure to start operation, like a sump pump that fails to operate because the water level rose so far and something didn't kick it in, so it didn't start. The switch was wrong or set wrong. Failure to stop operation. Press brake fails to stop when the interlock's activated. Something doesn't stop when it should. Failure during operation. Local exhaust system fails during welding operations, is an example of a failure. Degraded or deterioration of operation. Something just over time, and this could happen a lot of different things, but a leak in a containment vessel is one. Almost anything mechanical over time is going to degrade or deteriorate. So those are just examples of different failure modes, they're calling it. Oh, there's more. Exceeded capacity, capacity of operation. In other words, over pressurization of a vessel, overfilling a container with something hazardous, maybe it overflows. Reasonably foreseeable uses and misuses of operation, like using a forklift to raise a worker to reach equipment. That's a reasonable, foreseeable misuse of an operation. The result is to identify credible circumstances and potential failures that could arise and result in an undesirable incident or exposure. Each failure mode should include a description of the circumstances and events that can lead to the failure so that it can be understood. What are some circumstances, conditions, actions, or inaction that can cause exposure to or trigger a hazard? Well, okay, hazards too could be acute in nature, and we know what acute means, causing immediate harm, or chronic, and we know what that is too, causing harm from a prolonged or repeated exposure. They could be either one. You can get hurt right away, or it could take a while for it to happen. Basic causes may include machinery, the design, selection, condition, use, or maintenance of machinery. The wrong machine can be chosen. The condition, again, could deteriorate, can be used wrong, might not be maintained properly. All of these are basic potential problems with machinery. Humans, we know that humans are by definition not perfect. So their action, even their inactions, knowledge or lack thereof, skill, capability, attention, interaction, communication. These could all be basic causes of a hazard. Inattention. We all know that driving while distracted is one of the biggest causes of accidents on the highway. Management, they can be a problem too. Their direction can be wrong, supervision might be bad, enforcement might not be non-existent, or the communication might not be there. These are all things that can happen. Methods, design, method, the systems, the processes, the procedures, task consistency. Are we doing it the same way all the time? That could be a problem too. Materials, elements, constituents, selection, handling, storage, use, disposal. So the materials themselves may be a basic cause of a hazard. The materials could be wrong. They could be, again, deteriorating. The environment, layout, the design, condition, external factors, all could be problems too. Understanding how a hazard can be caused or triggered is critical to anticipating, recognizing, and identifying hazards and their risks. If there are existing controls in place, they should be identified and analyzed, including a description of their ordained function, effectiveness, and reliability. The anticipated or reasonably foreseen consequences of a hazard should be identified. The subject of its impact, people, property, environment, or other, should be identified. A general description of type of consequences associated with hazards is needed to conduct a risk assessment, which we're going to talk about a little later. We're just talking about risk identification in this module. Hazard identification methods can be simple or complex, but in general industry, they're usually quite simple. OHS, which is what? Occupational health and safety inspections, audits, checklists, and review of OSHA logs and our workers' compensation claims, interviews, or just plain talking with employees, and surveys are common. There are much more involved methods that can be looked into if needed. A review of previous audits, appropriate codes, regulations, and their consensus standards may also be used. What's a consensus standard? It's usually something that's done within an industry or a company that they've always followed, and they've adopted that as a standard. The risk management process generally consists of these steps. Again, establish the context, the risk assessment, risk identification, which we just looked at this one, risk analysis, which we're going to do next, risk evaluation, and risk treatment. Once again, identification of hazards is the most important step in risk assessment. If you don't know something is a hazard, you won't be able to do anything about it. Remember the clip about the guy standing on top of the train? You should have looked at that by now. He casually reached up to grasp the overhead wire as if it was a handrail. Why? Because he didn't know it was hazardous. There are several more videos that will cover the rest of this section. Each one, including this one, will have some questions that need to be answered. That's it for this module. So, see you next time.